Good morning, good afternoon, or good evening, wherever you are. Thanks very much for joining. I appreciate your time today. My name is Gareth Noyes, and I'm the Chief Strategy Officer at Wind River. I'll be hosting the session this morning. For the next 30 or 40 minutes or so, I'll be talking about the challenges of digital transformation focused on the new intelligent edge. Now, the edge is very different to traditional IT and cloud-like computing infrastructure, and I'll be delving on those differences. In particular, I'll be diving into the key drivers for digital transformation, and I'll highlight the unique challenges presented by critical edge infrastructure. So I'll outline new design dynamics you'll need to consider to be successful in this digital world, and I'll touch on the key skills that you and your organizations will need to develop to be successful in this transformation. And after that, we'll open up for questions. So let's dive right on in. So the world is digitally transforming. This likely isn't news to you. In fact, this journey is in full swing on the IT side of the house. So although computers have been around for decades, I think the internet boom of the late 90s, which drove ubiquitous connectivity, and the advent of cheaper computing that was much, much easier to use, enabled businesses to evolve and adapt the way they think about their business. Whether it was interacting online with their customers, tracking inventory, or focusing on streamlining their businesses through process optimization, or sometimes just automating tasks that were previously carried out by people. That transformation is pervasive across businesses, industries, and geographies, and only seems to be accelerating due to COVID. In fact, COVID seems to have poured both fuel and oxygen onto this transformation, and its pace has rapidly accelerated this year. It's not a question of if you transform, it's about how you transform. Focusing on managing digital transformation is really critical, and it's actually a constant topic of conversation for most executive teams. In fact, 68% of publicly traded companies report progress on digital transformation during their quarterly filings. And many organizations have created specific exec roles with a seat at the top table focused on digital transformation. And those companies that do have a chief digital officer are as much as 54% more likely to be successful in digital transformation than their peer organizations who don't. And so I think this is a recognition that digital transformation is real and part of everyday business. It's happening. It's been executed, managed, and measured, and specific executives have been given mandates for its success. Now, what you do to embark on digital transformation may vary from organization to organization, but the fact remains that it is a focus of business life. The majority of digital transformation efforts today are focused on things like business process or supply chain optimizations, basically automating and linking together business systems to digitalize processes, often replacing humans or manual tasks. But soon there'll be 7 or more IoT devices for every human on the planet. That's a very device-rich future. Edge devices are increasingly becoming a much more important part of the digital world too. And the mandate to digitally transform is shifting from a people-centric to machine-centric focus. And as we undergo this change, the way that we design, build, test, and deploy these machines and devices is also going to have to change. In fact, Michael Gale, an expert and leading author on digital transformation, goes as far as saying that digital success should be the #1 focus as we modernize our development processes for our organization's embedded technologies, which is critical at the edge. As I've mentioned, digital transformation is alive and well in IT, but the next frontier for innovation and transformation is happening at the edge. Now, the edge to me is the computing located at or close to the source of data. It's all the physical devices embedded in the world around us, whether it's cell towers connecting you to your cell phone as you roam around the countryside, or it's the ECUs in your car that are providing basic drivetrain control systems or enhanced driving features, or equipment managing the flow of traffic, keeping you home safe, or flying you to visit loved ones. But it's basically all the computing that you can physically see around you. You get the gist of it. Anyway, the edge is computing software that happens in the real world. And as computing gets cheaper, smarter, smaller, it becomes more and more ubiquitous in an environment. And it's not just the computing itself that accelerates its deployment. It's the advent of faster and more reliable connectivity. In fact, we're on the cusp of a connectivity revolution with the launch of 5G in many markets in the next couple of years. And as consumers, we tend to think of 5G as a generational evolution from previous 3G and 4G standards. But there are a couple of key differences with 5G that will accelerate rather than some machine-centric edge infrastructure. And the first of that is scale, massive machine scale, being able to service billions of endpoints with 5G. And the second characteristic of 5G that's incredibly interesting is its quality of service that will bring low latency and extreme reliability to wireless and really enable the flood of data at the edge produced by all the billions of IoT devices that are around. So the proliferation of computing devices and seamless connectivity means that the edge is where the majority of data will be processed in the future, and not too distant a future either. In fact, Gartner claims that 80% of all data will be processed at the edge as soon as 2025. Now, this is in stark contrast to early views of IoT architectures that saw sensors and devices connected to the cloud via gateways. And in those generic topologies, we saw most of the data being pushed northbound to the cloud. And in fact, that's been turned on its head. And we've now realized that we need to move the computing to the source of data, which is being generated and needs to be processed at the edges. So whereas the cloud has given us a good roadmap for how to build and deploy software effectively and at scale, the edge it's very different. It's not like a data center. So in a data center, hardware is fairly homogeneous, and that's changing, by the way, to embrace workload acceleration for AI and so on. So we see more FPGAs and GPUs and things emerging in the cloud. But the edge actually today is very heterogeneous. Devices at the edge are very, very different from one another. And most of them have been designed with specific characteristics in mind or tuned or tailored to very different needs. And in IT and comms, we see things like raw horsepower or throughput be very important. Although at the edge, we see diversity of characteristics that are unique, like latency, determinism, jitter, lots of timing attributes, security, functional safety. And this has led the edge to be in a world of bespoke devices. In tomorrow's world, though, the edge needs to be more adaptable. And while I don't think we'll see a uniform homogeneous environment like today's data centers, I think we will begin to adopt methods of abstraction and isolation that will allow the edge to look more uniform to applications. And this will be enabled by multiple levels of abstraction, whether it's hardware virtualization through hypervisors and virtual machines, or ultimately a fully cloud-native containerized compute model that will allow applications to run seamlessly on your desktop, in the cloud, or an edge device. The truth is, that's not the reality of the edge today, but it's the direction it needs to be headed to handle the scale and complexity of the edge. When you delve into the devices themselves, you see the different problems need to be solved at the edge. So a seemingly very simple but very significant problem with edge devices is the basic security model. So in data centers, physical access to computing infrastructure isn't that much of an issue. In fact, you can handle that easily with locked doors, fences, or badged access to IT infrastructure. But edge devices can be touched and therefore, even potentially dismantled. So even things like leaving pins on a board for JTAG debugging can represent a very real security threat for edge devices that you typically don't have to worry so much about in IT equipment. And devices themselves need to evolve and are becoming much, much more complex. So take, for example, the basic CPU architecture, which has shifted from a single core to multi-core to overcome basic physics that prevented higher and higher power at smaller frequency. And now we're talking of needing to enable multiple compute architectures for acceleration for AI and machine learning. So now devices are much more complex and may contain neural networks, FPGAs, GPUs, or other compute engines. So that diversity of hardware is very significant at the edge and is very different. So with this increasing complexity and being on the cusp of a new generation of 5G networks and a push towards more automation and autonomy, this is going to create a huge deluge of data, and so we need to simplify and vastly improve how software is built at the edge. This creates an imperative for us to fundamentally change the way we develop, build, test, and deploy devices. It's really time to modernize our approach. Now, the need for modernization is being recognized by companies that are successfully digitally transforming, but they also recognize it isn't easy. They know the digital transformation is volatile, creates a lot of uncertainty, is highly complex and ambiguous. But despite the challenges of transforming, companies recognize that they must do so in order to reap the benefits. Now, AI may seem like an overused buzzword to you. Many companies see this as an opportunity to help them drive new revenue streams or solve new problems. AI, in fact, will be an imperative in our data-rich future. And it's not just the new and appealing use cases that drive AI proliferation. Even seemingly mundane or generic reasons, such as lowering costs, are driving AI adoption. It's not just the ongoing march of technology for the sake of it. It's the explosion of edge devices generating mountains of data that are going to force a different approach to development. As I mentioned earlier, the cloud has given us a roadmap for how to develop software efficiently and at scale. In fact, over a third of all developers surveyed are currently building cloud-native architectures. And an additional 30% plan on doing so next year. Adoption of modern cloud methods and architectures is in full swing. And although that's beginning with the cloud, we see that moving rapidly towards the edge. In a recent Eclipse Foundation survey, many automation technologies felt completely unprepared to tackle the challenges associated with smart machine technologies. In fact, top of mind were some of the ones we've already touched upon, including security, connectivity, and what to actually do with the data and how to analyze and collect it. But with those concerns in mind, how do we tackle them? I think it's time to go back to the drawing board and rethink how software is built for the edge. If you look at the way that software is developed for edge infrastructure today, you'll notice there's a very close coupling to hardware. Developers iterate in what I call an edit, compile, debug paradigm that is very manual and focused on iterative and incremental improvements. And different elements of the system are often developed in silos. Development teams often prefer to develop with hardware-in-the-loop systems that gives them the best fidelity for performance in a real-time system. But this approach leads to silo behavior, a sequential approach to development, and a lot of manual development and testing that is harder than it should be to automate. In fact, the current approach leads to a very hardware-centric approach, where design cycles are repeated over and over again. I design the hardware platform, I layer on an operating system tailored to that hardware. Incrementally, I add middleware, applications, and so on. Now, I may have some layers of abstraction in my software that allows my teams to decouple dependencies. But by and large, my development cycle is just a treadmill of one hardware generation design after the next, layering software until the next design cycle starts again. But we need to change this paradigm and think of software as a constantly evolving stream of value. The notion of building a device once and deploying forever, a build-break cycle is what I call it, that needs to change because needs evolve and devices must be adaptable over their life cycle. Now, this may be counterintuitive if your business model is that you monetize each new version of hardware that you release, but it becomes an imperative if you take into account the evolving need for security updates, for example. Or some companies are viewing this as an opportunity to deploy new functionality to their customers after a device has been fielded. In fact, consumer companies in particular have embraced this paradigm. They understand that evolving and improving their products over time can lead to customer moments of joy, which turns into brand loyalty. Think about the loyal Tesla customers, for example, who will endure sometimes suboptimal features, but they know that they'll be improved and enhanced over time. That thinking starts with accepting the notion of edge devices needing a managed lifecycle. To enable our developers to more productively build code and do so frequently to adapt to evolving product lifecycles means that we also need to rethink the basic tools and edit, compile, debug loops. So we need to empower developers to maximize their creativity and enable them with modern workflows, tool chains, and languages. Really allow them to leverage the impact of broad developer ecosystems who are sharing knowledge and best practices. Now, if we look at choices of computer languages, for example, embedded developers have traditionally used low-level languages like C, C++, or assembler. Newer generations prefer richer and more productive environments like Python or Rust. Rust, for example, would be familiar to C++ developers, but it's taken off in some domains because of the intrinsic security the language encourages. It's like a modern Ada. If we look ahead, we see that low-code or no-code environments will become more attractive and more pervasive. And this will be critical as developers evolve from being computer scientists to domain experts who are using software as a necessary means to accomplish a task. Adapting to this shift in developer capability and preferences is critical. It's not just a matter of domain experts taking over from computer scientists, but actually many companies in critical industries such as industrial systems or aerospace and defense actually voicing concern about their aging workforces and their inability to hire new talent. In fact, when companies are able to hire, they're faced with a younger population of developers who express completely different expectations about the tools and processes they use. So edge development really needs to become more familiar to this new population who are comfortable with Python or TensorFlow, say. With this imperative to change, let me share some of the key design dynamics you need to consider. So first of all, we must break down silos amongst our development teams. This is one of the biggest inhibitors of digital transformation. We've got to evolve where electrical engineers are only part of the team and where optimization of the whole is not sacrificed by the detail. And teams and functions can work seamlessly together. It's going to be about getting teams aligned on solving the big problems and maintaining a system-centric view. Secondly, we've got to stop thinking that our job is done once the device has been fielded. The entire life cycle of the software, from development through to decommissioning, needs to be managed. The build once and ship forever tradition where updates and servicing is someone else's job needs to evolve. In fact, technologies like 5G and other connectivity technologies will make over-the-air updates much more common practice. Then the notion of scale changes when the world has 40 billion devices, or when applications are deployed with millions of lines of code. The bottoms-up approach of laying software breaks down, and the notion of scale becomes redefined. For cloud developers, the notion of scale is second nature, and this is where approaches like containerization and automation were born. Whereas the system view is important, so too is the detail. Edge infrastructure is often critical and deployed in can't-fail scenarios. That means the functionality has to be guaranteed and system uptime is paramount. That places limitations on how systems can be upgraded, for example. We cannot stop the car to change parts. The interplay of individual elements with the overall system must be well understood. And as we move to more data-centric deployments, AI will be critical to extract insights and meaning. In turn, the AI depends on having accurate and timely data that ensures a context is not stale or moment hasn't passed. So real-time notions will have to be coupled to AI systems for a truly intelligent edge. And security has always been a priority. Historically, that's been security of the platform itself. At the edge, physical access to device changes the nature of security. So too does AI, where security means managing the data and fidelity of machine learning models. Building intelligence and adaptability is key for a secure and every moment construct. Today, the edge is largely populated with physical, fixed function devices. Soon, that will increasingly be augmented by cloud-scale infrastructure housed in the world around us, in our cities and municipalities. And as we evolve the way we build physical devices, we must adapt for devices coexisting with cloud infrastructure, and over time, for that distinction between the two to blur. Now, for that to happen, we've got to evolve our development practices so they're more similar across the two, so that ultimately where software is run is going to be a runtime orchestration issue, not a development choice. But our development paradigms aren't aligned today, and we still need to master development paradigms from different computing domains and start adopting best practices from each. Now, we focused a lot on the discussion so far on development. As we've mentioned, we need to expand our view beyond the development phase to extend it into the complete lifecycle. And with that in mind, let's turn our attention to the deployment of software at the edge. As systems become more complex and time to market pressures increase and security models continue to evolve, thinking that deploying products with feature completeness is not practical. Instead, taking a highly secure, minimal viable product to market and making enhancements over time will become more normal. I mentioned earlier consumer examples, and we're starting to see a move in that direction in automotive too, with automotive systems being upgraded overnight. In fact, we're starting to see defense procurements evolve in that direction too. So I've mentioned several times that cloud native has given us a roadmap to new methods for software development. In fact, cloud native has shown us that it's not only what you build, but how you build it that matters to achieve productivity and scalability. So first of all, cloud native is often synonymous with microservices or containers. That's the what. In fact, what is key is the level of abstraction that these technologies enable. By developing software that's packaged in a certain way, it allows the deployment of software to be orchestrated much more intelligently. Secondly, how software is developed is paramount. To achieve scale and efficiency, high degrees of automation are necessary. And so DevOps, or DevSecOps, has become the norm for cloud native and enabled the massive gains in productivity and value creation brought about by the cloud revolution. Cloud native extends well beyond the develop phase. In fact, most cloud native environments, the distinction between the develop and operate phase are transparent, hence dev and ops. The notion of continuous delivery of software is an integral part of cloud native and lends itself to thinking about the complete lifecycle. Cloud architectures often go further, and containers are often immutable. That means they can be completely replaced with a new version, making updates of individual components or services very easy. The broader picture here is that to successfully enable our teams to build solutions for the new intelligent edge, we'll need to enable multiple developer personas, each with a distinct area of interest or responsibility, working together seamlessly through multiple connected workflows, which enable support of the complete lifecycle. So before we draw this session to a close, let's spend a few minutes highlighting some of the skills you need to ensure you nurture within your organization. We've been talking about the need to break down team silos and enable multiple types of developers and ensure they work seamlessly together and are able to collaborate through their task-focused workflows. This means you should be thinking of building a portfolio of skills. So let's review a few important ones. So the first skill should come as no surprise to anyone who's been reading any tech blog or media in the last couple of years. With data and vast amounts of machine-generated data being at the core of digital transformation at the intelligent edge, ensuring you have AI competency across your organization is key. Now, as technologists, we tend to focus on the bits and bytes of technologies, and we tend to think of machine learning frameworks like TensorFlow or PyTorch, being key AI capabilities. They are, of course, but equally important across organizational capabilities, such as the ability to frame the right questions, applying discipline to your G&A processes such that they become data-driven, and ensuring your leadership and management teams are nurturing data across an organization, in addition to managing people or processes. This is where the role of Chief Digital Officer that I mentioned earlier becomes critical. Now, AI and machine learning are not valuable without correctly curating your data. You'll need to ensure not only that you're collecting the right data, but that it is timely and with the right context. Data doesn't always age well, and the benefit of doing more processing at the edge is because that's a context-rich environment. A massive data accumulated in the cloud may be easy to store, but it may become a nightmare to mine. So designing your system with data at the forefront of your architecture is paramount, and it can't be left as an exercise to the user. The vast scale that comes from richer, intelligent edge, whether it's the number of devices or nodes that's growing, or the vast amounts of data being generated, means that automation of deployed systems is paramount. Now, many systems deployed at the edge today are already automated, and those are often evolving to become more autonomous. Similarly, the process by which we build, test, and deploy software needs to become increasingly automated. Today, a lot of software development and testing steps include some manual processes or necessary interventions by engineers. Now, to address the new intelligent edge, the develop, test, deploy paradigms need to be fully automated. It's about getting teams aligned on solving the big problems and maintaining a system-centric view. Now, earlier I've mentioned that initial IoT architectures favored moving data to be processed in the cloud. But because of cost, latency, bandwidth, or a whole host of other issues, we saw that processing is increasingly being done at the edge. That doesn't mean that devices and infrastructure are independent of each other. In fact, sharing of information and context across the edge is very important. So connectivity is key, and in addition to proprietary bus protocols we see in many verticals, IP networking is still relevant and growing as a backbone of many topologies. We see, for example, that protocols such as TSN or time-sensitive networking are emerging as important standards in critical domains. All of these based on an IP foundation. We also spoke earlier about the edge being different from the cloud. A big part of that difference is the diversity of hardware and computing environments. So while there's a move amongst software developers to high levels of abstraction, whether it's frameworks and programming languages or no-code, low-code programming, the reality is the edge is comprised of physical devices that look very different from one another. Understanding these differences or concepts, such as how the operating systems work, for example, will still be valuable and will set you apart from the crowd. Amongst the diverse edge environments will also be mobile devices. Not only are they ubiquitous from our personal and professional lives, but they're evolving to become the interface for interacting with edge equipment. For example, field or service personnel are using augmented reality to automate aspects of support. So architecting the mobile experience into this rich environment is something that needs to be considered as part of your overall design. Interacting with intelligent systems through mobile devices is only one aspect of the user experience. So due to the rising complexity of systems and diversity of experience of those using the systems, from experts to non-experts, building intuitive and easy to use interface is going to be paramount. And let's face it, outstanding UX isn't always best left to a bunch of embedded engineers. Luckily, there's a growing recognition of that being the case, and UX expertise should be part of your team's skills portfolio. Now, this list of skills isn't ordered in importance. Otherwise, you'd have expected security to be close to the top of the list. But information security and security generally is raised as a key concern in most developer surveys. And the need for security expertise persists as much as its scope expands. In fact, developers not only need to know about the key building blocks in technologies such as SSL, or development best practices like secure development lifecycle, or security-focused testing approaches like pen testing. But they also now need to be aware of compliance to standards such as NIST 853 or IEC 62443 that are attempting to apply some uniformity of requirements to the landscape. So all these aspects are important in order to have a good security model. Now, focus on collecting, moving, and storing all the data from systems is important, but knowing what to do with it is critical. So knowing what pain points or use cases you're addressing for your customer, and therefore what data you need to collect and what signals to look for, is all part of you delivering your business value to your customer. So don't lose sight of those problems and which customers you're serving. In fact, raise your nose away from your keyboard and take time to reflect on this regularly. Finally, one of the themes that we've hit on several times today is the need to break down silos. Specific expertise is important, but so is a diversity of expertise. The world is becoming more complex, and we can't expect a single individual to amass all the skills to solve every problem. Increasingly, we need to think about a diversity of talent and skills distributed in teams across geographies. If there's anything this COVID experience has shown us, it's the need to perfect collaboration across digital boundaries. So we've gone slightly faster than I'd expected, and we've come to the end of the presentation today. I'll leave you with a few thoughts though as you digest the content of the material we shared. Digital transformation is happening. It's already here and in full swing in IT, but it's rapidly expanding to the intelligent edge. And as that happens, systems become more and more complex, and we need new ways to adapt to this complexity. So combining skills, tool chains, and methods from both cloud environments and embedded domains becomes increasingly important. And we need to rethink and retool how these systems are built. So helping you succeed on that journey is Winriver's passion and focus. So we're here to help. On this slide, there's a landing page where you can download a white paper with facts and references that I've been talking about. And if at any point you want to reach out, feel free to do so. Thanks for your time today.